Hey Algebra 1, it is the weekend before your EOC, and I'm so excited that you're watching this video and getting some good hints about your EOC. Um, I'm going to be working in your orange book, so if you'll please find your orange book on page 25, and if you don't have your orange book, then just watch and learn some stuff about linear versus quadratic. Okay, a little bit of announcements. Reminder, second period, your exam is the morning of Monday 20th in 4:08. Third period, your exam is the afternoon of the 20th in 4:01. And fourth period, yours is the afternoon as well, and y'all are in 4:06. So, um, remember where you're going, and if you come to the breakfast or the lunch, I'll remind you where you're going for your exam. Okay, I want to compare linear graphs with a quadratic graph, and look at the equations. The equations are practically the same, like 3x versus 3x squared. And they're both at -2. So both of the constants, the number off by themselves, they're both at -2. So I'm going to use my calculator to do this, to make this table. I just want to get some numbers really quick on my calculator, and just so you can see one more time how to make a table in your calculator. I'm going to type this in as a graph to start with. And type in the equation. I'm going to do linear first, 3x minus 2. So that's what I can expect of the line. Not really surprised. I can see it crosses at the -2 right there. I can see it goes up by 3 over 1, which is what we expected from our slope, right? 3, 1. Okay, so we want to make a table. So I'm going to do menu, table, and split the screen. We like to start at -2. Remember, when you make a table, some numbers should be negative, some numbers should be positive. So I'm going to go up here. I'm just going to copy that table down on my workbook really quick. So -2 is paired up with -8, -1 is paired up with -5, and then it goes up by 3. Duh, that's what the slope said. The slope in the equation was a +3. Let me write this on my workbook. So if the input was -2, the equation would output -8. -1 would make -5. 0, -2. Remember, the most important point on a table is -2. -2 shows up in our equation, so we kind of knew that was coming. 1, 2, oh, 1, that's convenient. And then 2 to 4. I'm just going to put those on a map real quick. Do the same thing on a map. -2, -1, 0, 1, 2, -8, -5, -2, 0, 1, 4. And what makes a map special is that there's actually lines connecting the input to the output, the domain to the range. And then I'm just going to draw that graph real quick. So just plot some points. Sorry.
Mr. Dandy or someone in maintenance, please. Would you please call the main office? Maintenance, please call the main office. We need someone to go for a cleanup in Ms. Peebles' classroom.
So in case you were missing school over the weekend, interruption by the announcements, that's pretty right? That's pretty accurate. Okay, so I applied the points while they were being paged, maintenance was being paged. I got a linear line. Goes up. How do you decide it's up? The right side tells you whether it's a positive graph or a negative graph. So the right side here is a positive graph. Tells me it's a going up graph. In the directions earlier, it said show the parent graphs. We know that a basic line goes through the origin and just counts up by 1. So I'm just going to put the dots for a parent graph. But what I'm seeing here, what makes this linear is that it has constant change. So what makes this linear is that I can look on the table. Okay, obviously the graph makes it linear. So like, this is a line. So it's linear. But if I didn't have the graph in front of me, I could look here and see that I have some constant change. It's going up. +3, +3. That constant change is what makes this linear. Now, the difference between linear and quadratic. Oh, I'm so excited to share this. So I'm going to go back and change my equation from linear to quadratic. The equation is 3x squared minus 2. The squared makes it quadratic. What shape are you expecting on the graph? Think of the word parabola. So you're expecting a U-shaped parabola. Skinny parabola or wider parabola? Is the A a bigger value or a smaller value? So we're expecting a pretty skinny parabola because it's by 3. Let me type it in real quick. Okay, so I'm going to go back over here to my graph. You see what I've done? I've put it back over here to my graph. I'm going to press tab on to my graph on this side. Get this table off. It's getting in the way. Remove table. Okay, back over here to my graph, and instead of 3x minus 2, I want 3x squared minus 2. And there's a parabola. It's a little bit skinny. Look, it crosses right there at -2. We were expecting that because that's the number by itself. But it crosses right there at -2 on the y-axis, and it just goes up in a kind of skinny manner. I need to put these numbers. So I'm going to make a table real quick. I need to put these numbers on my workbook. So -2 and 10, -1 and 1. Let me write that in real quick. -2 and 10, -1 and 1, 0 and -2. And then watch what happens. Watch what happens. This is what makes this parabola. So here's the kicker. Look at this. It starts repeating itself. There's symmetry. We call this the axis of symmetry. It's like a butterfly on either side of the -2 there. We have some symmetry. So we have +1 being +1 and +2 being 10, just like the negatives. All right, so watch how I'm going to do my math. No repeating x's, but I had some repeating y's, and that's okay. Numerical order. All right, -2 went to 10. -1 went to 1, 0 to -2. Watch this, because this is still a function, even though there's some repetitiveness happening, not in the x bubble, but in the y bubble. 1 to 1 and 2 to 10. Of course, it looks like a parabola on our graph. So 1 to 1, -1 to 1, 2 all the way up here to 10, -2 all the way up here to 10. Oh, maybe I can make this somewhat of a fair amount of a parabola. Oh, that's pretty good. Okay. All right. So parabola, is it a positive, negative parabola? Looking over here on the right side, we see that the right side is pointing up, so this would be a positive graph. The end behavior always happens on the right side of the graph. To follow that direction is about a basic parabola. Remember, basic parabolas, everything goes to the origin. All the parent graphs go to the origin. And it's just squared. So like, what's 3 squared? 9. So here's just a regular, plain old parabola. Look at this. It's a little bit wider than what we have going on right now, which is true because a plain parabola is just x squared. We have 3x squared, so ours is a tad bit skinnier, more narrow. All right, how do you find if it's, how do you see constant change in a parabola? Watch this. 10 down to 1 is -9. 1 down to -2 is -3. But going back up, -2 back up to 1 is a +3, and 1 up to 9 is a +9. Now, that's not constant, so that's how we know it's not linear. However, the exponent of 2 says that we should probably have to count out the second time, do that again one more time, and then we'll see some consistency. So -9 down to 3, I'm sorry, -9 up to -3 is a increase of 6. -3 up to +3, increase of 6. 3 up to 9, increase of 6. So we have consistency in the second degree. So there's still constant change. So the difference between linear and quadratic is not the fact that there's constant change, because there's constant change in both. But in quadratic, we had to find constant change in the second degree because of the exponent, x squared. Another thing I want to point out is that both of these graphs had the same y-intercept. They both have the same y-intercept of -2. Remember, the number off by itself in an equation, is going to be the y-intercept. No matter what kind of equation you look at, the number off by itself is going to be the y-intercept. I'm willing to wager that majority of your test is either going to be linear or quadratic. So there's going to be some exponentials sprinkled in, but really spend some time this weekend looking over linear and quadratic. Spend some time in the practice sections right here in the pages prior to here, page 25. But that's the difference between linear and quadratic. Now you know. Good luck studying.